Let's run through this. Mention again the checklist. It looks a bit like this. Your hospital organization at the top. Who you are is there because we'll be getting back in touch with you. We know your email address, don't worry about that. What facility, when you did it. We will write in for you. See at the top there are your energy metrics, which is your target savings in terms of base thermal, which is this, kind of what you see through the summer, the heating, thermal, the extra use in the winter, and emissions. Don't worry about that. We'll fill that in for you, and it'll be filled in when it comes back to you. So that gives you an idea of where you're. Are we looking to save 2% or 60% of our gas consumption? And then the rest of it should be fairly clear. It's there are 3 sections: one on plant configuration, second on operations, and the third on extending plant life. And you just fill in, we already did this, we plan to do this already, this is on our agenda, that's a good idea, I'm going to think about that, I'm going to take it back, and this doesn't apply to me. So it's pretty straightforward. When we summarize these things, they're incredibly powerful, because now you're getting the mood of a large number of hospitals, and that allows everybody to focus on the things that matter most to you. The notes are there for you to fill in as to, I need to talk to Mary about making that happen, and I can't remember who my service contract, whatever it is, those notes are for you to work through, but we will transcribe those into the copy as well. So here's our panel. I'll introduce them. Brent, Director of Facility Operations at Southlake. Southlake, with many of you, John Marshman is there right now doing all the things that John does, and that agenda is moving forward very fast. Paul Ingham with Thermogenics, working with Southlake on what we're going to show you, the profile of the measures they're looking to implement there. And we invited John Federico to come in because it sounded like deja vu all over again with John, that he's been doing many of these things at West Park for many years, and we'll be asking John in places to say, yeah, I tried that, that didn't work, tried that, had these problems, and so on. So it's very much conversation. We haven't rehearsed, we've talked about the flow of this thing, so it could go anywhere, and again, you're part of that conversation, so please make sure you step in. So if you don't know Southlake, there it is up in Newmarket. And if you don't know what that banner looks like at the bottom, every Greening Healthcare member, that's your kind of your medical record. So in the case of Southlake, it's quite an intensive energy user right now and has all the right intentions of improving that. Where you see Base Electric, for example, they're using 27.7 kilowatt hours per square foot per year. A target for an acute care hospital of that nature is 20.6. So that's the savings target, which is fan power and lighting and all the other things that they'll plan to do. The cooling electricity is the extra use in the summer. Base thermal is the year-round gas consumption, which is the biggest single opportunity. And that speaks to the boiler plant, right? So a lot of that is reheat in the air handling systems, which is the load, but it's how the boiler plant runs through the summer, and the extra heat in the winter actually is not that unreasonable, and we'll talk some more about that. So this is the profile, if you like, that every hospital in Greening Healthcare has. It's kind of just running the monthly utility data, comparing it against good practice standards, and telling them that you can save $1.374 million a year. That's bogey, that's their target. Just by running the plant they've got more efficiently. This is not aspirational. So that's Southlake. Here's what we see when we track the savings. So again, we're looking at these numbers for every one of the member hospitals every month. And back in February of 2022, the hospital Thermogenics installed linkageless controls on the boilers there, which Paul will explain when we get to that point as to how does that improve the efficiency of the boiler plant. Just a single measure, and what we're going to be talking today about, what more could they have done and what more are they planning to do right now? What is that whole shopping list that's in the checklist that you have in front of you right now? But you see the red dots are the weather normalized baseline from the previous year. The blue dots are the actual monthly usage. Whenever the blue dots are below the red dots, that's real savings. So over this period of the last 12 months, as a result of that work, about 4% total gas savings on the whole hospital. And Julian was and Enbridge were good enough to provide an incentive towards the cost of that work. And it's 127,000 cubic meters. This is a big hospital. That's a lot of gas. And that's a lot of greenhouse gas emissions. So this is a success story, but the quarrel Greening Healthcare had with Paul was, why are the savings in the winter bigger than the savings in the summer? You should see much bigger savings in the summer when the load's lighter. That's when it should work better. So that started a whole conversation with Brent and Paul about what do we miss? What more could we do? When you connect these results to the work that was done, what are we all learning, and how can we further improve the savings? So what's planned now? Here is the boiler plant, and I'll show you some more pictures in a moment. But the linkageless controls installation we've mentioned in February of 2022. Now we're looking at boiler pressure reduction, and the hospital is rightly just making sure that the sterilizers are comfortable with that, looking at automatic sequencing of boilers, and we'll be asking, again, I think Paul with Brent's color commentary and John's kind of contribution from the left. So automatic sequencing as opposed to the operators deciding which boilers to run when, typically in pairs. The shutting off the feed water supply to economizers when the boiler's not running, so effectively they're not giving the heat back from the condensate going in there. The economizer bypass controls and the draft dampers are questionable. So, Paul, can you start with, tell us about those measures and where do they apply, what do they do, how do they work? And again, this is for you. If you have a boiler plant, and all of you do, think about your questions now and let's put them into the mix. But Paul, give us a start on these measures.
Do you want to start with just linkageless controls? And can you hear me? Do I need this thing?
I think you need it. Yes, please, because then we're picking it up on the recording as well.
Okay. Just to better understand linkageless controls. So for those that may not understand combustion, basically you got fuel, you got air. If you run your combustion mix with a little too much fuel, you run rich. So that means you can have fuel that's not combusted in your system. It can be dirty, it can be inefficient. If you go on the opposite side of that, you run too much air, you run lean. So now you're not utilizing all of the fuel you just spent a bunch of money on. And so what we always try and achieve is as close to perfect combustion as possible, right? That perfect gas and air mix. Now, in reality, that's next to impossible to do because there's so many factors that play into that. But what linkageless controls allows for, and this technology has been around for 20 plus years now or more, it just allows you to meter the gas and the air specifically across the entire combustion curve. So traditionally, you would look at, say, fuel input, and you would measure an approximation of air across your firing range. Well, linkageless allows you to set up all the way across that curve. So as we get into things like the draft, for example, as you become really, really well-tuned in that combustion process, think of like a race car, for example, everything else becomes important. Pressure becomes important, air density plays a factor, draft becomes very, very important. So everything that goes in has to be very well measured, very well controlled. So pressure, flow, and on the exit, it's the same. And we're in a climate here in Canada where we have very significant seasonal change. And so you can measure and control input all day long, but if you don't control the draft on that boiler, you lose the ability to maintain that tight gas-air ratio just through draft, right? So now you're drawing through the boiler. So every time you add excess air to combustion, you actually decline in efficiency. So that's just a bit of an overview on how linkageless works, why draft and pressure is important. Input-output control is just as important as anything else.
Let's pass that to John for a moment. You've been there, done that.
Yeah, been there, done that. I agree with what you're saying. We've done a lot of work with linkages when we went that route, and I think the key with that is having the proper setup, for sure, 100%. And I do a lot of that with my subcontractors. And they come in, once every 6-7 months, and we just check to make sure that the fuel is proper and it's doing what it needs to do. But Ian, you're right. We've done it. It works. We have old boilers, so it's been working pretty good so far.
And Brent, just getting into that, because then we'll look forward, but that leakless controls, what kind of decision was that for the hospital to, it was probably six-figure investment, right?
Yeah, we were actually fortunate enough to utilize FERC for
Okay.
upgrades.
Yep.
So due to the change in one of the projects, I was able to have some additional funding, which, you know, obviously helps. It's always difficult to get capital funding in a healthcare center, I'm sure as everyone's aware. So, and additionally, you know, having conversations around, you know, the potential paybacks, it's a lot easier to get commitment from the organization in order.
And how confident were you with that? I'm sure the Thermogenics were there saying, trust us, this is going to work. Where did you get your confidence from that, yeah, this is an investment worth making, it's going to work out?
Yeah, just from conversations with, you know, some of the peer hospitals and people who have been there, done this, and even conversations with folks at Thermogenics, and additionally some conversations with Enbridge. We were confident that we'd get the payback that everyone has spoken about.
And Michael, can you bring and then I want to hear from Julian as well as to where Enbridge fits into this, but microphone kind of.
Thanks. Just a couple quick questions. The first one's for John. The graph that was put up showed about a 4% savings for linkage list controls. Was that what you experienced at West Park as well? Yes. And then the second question is just around the cost. Six figures is a wide range. Was it closer to 100,000 or closer to 900,000? And what was the scope of that investment? How many boilers covering how many square foot?
I don't remember the exact cost, but I think it'd be close to $100,000, or 900,000. And yeah, we did all four boilers when we moved forward with that. And as we're going to speak about, we're going to look at some additional enhancements that we can do as well.
And Julian, you were, yeah, go ahead, Archie, please.
Thank you. My question is to Thermogenic and John, both of you. You mentioned that leakage control, every 6 months you bring your contractor to do. Does this require a regular calibration so it'll do the job which is supposed to be do, or is annual? And I'm just looking for Thermogenics also because you guys can tell me if something is required, because I have the thermogenic boiler before in leakage control, but we never did the calibration. So we want to know that if something is required to have it, do calibration regularly. Thank you.
My recommendation is absolutely bring in your service technicians even 4 times a year, right? We go through significant seasonal change, and you know, that needs adjustment all the time. I mean, I think Enbridge at one point was even incentivizing what they call factory recommissioning. So essentially coming back in there, checking your gas and air, and if you don't have control over those in and outputs from a pressure perspective, it absolutely pays off. So I think quarterly, semi-annual for sure, is something everybody should be doing.
And is there any compatible leakage loss control? Because when you're running the thermogenic boiler, you have to, there's quite a bit of different models available in the market.
Yeah.
So with the thermogenic boilers, what kind of a leakage control you recommend?
You can put any on. And I think, you know, that's an excellent question, because I don't want everyone to think you got to put 6 figures in to get a linkageless system. There's more to that decision. Depending on the tenure of your boilers and the flame safeguard that's in there, there are bolt-on packages that are half the price to still get fuel-air ratio control. So, you know, you can achieve the same results, but it's very specific to what your current system has. But there are several brands that you can utilize, and we've used them all.
And I think, John, your installation, it was 125K, I remember. So, Julian, can you talk about where Enbridge fits into this?
Yeah, so for our leakageless controls project, for us to estimate the savings, I don't think it's that difficult. We pretty much are looking at excess air that's going in right now and then reducing that down to, 3% O2 as a target, something like that. So I'd say if you're interested in doing a project like this, reach out to me early. We can estimate the savings for you. We can estimate an incentive to kind of help offset that capital cost and make the project more attractive and more feasible.
I need to play the economics. I believe the incentive was something like $26,000.
Yeah, for Southlake in particular, it's $26,000.
And looking at the 127,000 cubic meters a year, that's about $35,000 a year of gas. These are good economics, but it starts, as you say, with measurement testing, making sure you know what you've got to start with. So let's step through here a little bit. So that project was done. We showed you the gas data, which is greening healthcare's bid. We keep the score. And the results weren't what we expected. We expected them to be a bit larger, and in particular, to see much bigger savings in the summer when the loads are lighter and the linkageless control should work well. So when Southlake and Thermogenics and Greening Healthcare look at the numbers together, and we met on site and looked at the plant, it was what else can we do? So these other things here. The plant operator was already playing around with reducing the steam pressure. Steam pressure improves the efficiency of the boiler. So now thinking about putting that in place, but not just the operator hoping, turning it down and hoping nothing goes wrong, but it's the conversation. It's everybody together in the boiler room talking about how to do it, what it would look like, who to check with. So the Steris decision, let's talk to the sterilizer folks first to make sure they're okay with that. But bringing down the steam pressure improves efficiency. The automatic sequencing, when we look at the boilers, you can tell us, Paul, where we see that, and you can explain how that benefits. So when do you switch from one boiler to two? It's a big decision, it matters. It's looking for the sweet spot on efficiency. This idea of the feed water supply to the economizers, love you to explain how would that be done. So, an economizer is the feed water goes through the chimney, the stack, before it goes to the boiler and recovers heat. But when the boiler's not running, it's giving heat up. And as Paul mentioned, the draft, that heat then goes up the chimney and goes away. So shutting that on. So fairly simple conceptually, but technically how does it happen? And we'll look at the economizer and the fact there are bypass dampers. We'll get into that once we get into the pictures. But also the draft damper. And if we start down that path, there's a lot of draft on those boilers. Like, wherever did those chimneys come from, Brent?
Yeah, to be honest with you, I'm not sure. But they're pretty much the tallest thing in the town of Newmarket anyway. Probably.
Just picturing, if you put a little railing around the top there, you could be jumped.
Yeah.
Right, like you see in town?
It's actually neat to watch them do the inspection on those as well. They have quite the setup. So.
Makes my knees wobble. Paul, what kind of issues does that make? Because the higher the chimney, presumably the more it's trying to pull the air through the boilers and costing us energy, right?
Yeah, I mean, a stack that big, especially in the winter, will create draft that'll pull your hat off, right? Like, there's a significant delta between winter and summer in terms of how draft is going to play on that. And we've seen over the last few days with the weather we've had, you're still getting fairly cool mornings, sometimes with some upset weather conditions in the middle of summer, and then it's 30 degrees out in the afternoon. So, like, across a stack that big, that is a significant change in draft. And that will have a significant impact on combustion, if not control.
So let's keep running through. Here's the boilers. You pick up what you want to talk about it here, Paul. And so they're your pitches. Go for it.
That's just a look at Brent's new boilers in terms of the linkage list. I don't know if Ian, you want to point out just like how the actuators, if you're not familiar with it, linkage list essentially puts direct drive on the fuel and on the air. So rather than having long linkages that can get play and slop in there, the actuator itself is directly on what measures your fuel and what measures your air. These boilers also have variable speed drives in the combustion air. So, Brent's running potentially half the capacity of that boiler with a 20 horsepower motor. Why run that all year round when you can cut that in half and then control combustion a little tighter because of it. You can see the external economizer too in the background. So Brent's had non-condensing flue gas economizers installed since the beginning. But some of the things we identified on a visit was some of the positions of the damper. So there's a damper in the middle of the economizer that forces the flue gas out through the heat recovery exchanger of the economizer. We actually couldn't identify if they were open or closed because some of the actuators had failed over time. And of course, they're way up, right? It's very difficult to see. It's very difficult to verify. And so those were some of the low-hanging fruit items that we're going to go chase down now.
And Paul, looking at that ABB on the right-hand picture there, is that a variable frequency drive?
That's the variable frequency drive.
And that's on the draft motor, right?
That's on the combustion air, yes.
And as you say, that's a big motor. And did you install that at the time, or was that already there?
I think that was part of your upgrade, right?
It was part of the upgrade.
Yeah.
Okay.
And it depends, right? Like you can stage the stuff. These days, that's a very cost-effective measure to add at any time.
So Vicky, there's big electricity savings there as well. These are big motors, and the idea of linkageless sounds kind of benign, but when you see boilers with old linkages on them, anybody remember Meccano? Does that exist anymore? Yeah. So it's like pieces of Meccano together with little bolts on them, and you see them flopping around, going around. So you can imagine trying to maintain that precise mix between how much gas is going in and how much air is going in. It's impossible, and it's not repeatable. So as the load goes up, you get completely different efficiency curves when it comes down again, because the linkages all shifted. So as you say, conceptually very simple, not that expensive, tremendous payback. And again, with your questionnaire for every hospital, if you don't have it right now, please mark that. And again, we're not going to sick anybody on you. We're just going to be there offering whatever coaching we can. And I think we put on there, if you can indicate on there whether you're comfortable for Enbridge to approach you on this, then I know Julian would love to follow up. And they are the best technical support advice you can get. Let's keep going through that. Paul, will stay with you on this. What are we looking at now?
I think one important aspect of the photo on the left, you can see how two of the boilers go into a combined stack. So as we start looking at how we're going to tackle kind of the next phase of this project for draft control and heat recovery, there's two major aspects that we're concerned about. So one is, of course, draft. Like there's significant draft across the two boilers. What happens to the boiler when it's offline versus the online boiler? But also as we re-engage the economizers and we maximize heat recovery, with a stack that tall, we're concerned about condensing in the stack. So we're going to implement measures where we're going to ensure we can achieve the maximum heat recovery while still keeping the temperature in the flue hot enough that you get the flue out without changing phase and corroding out that stack. So delicate measure there, but something that's easily achieved, I think, with current technology.
So when you say condensing, that's not pure water, right? That's nasty stuff.
Well, it's slightly acidic. It is
yeah.
pure water, but it is slightly acidic because it's from the byproducts of combustion, so it can corrode if it's not all stainless steel, but it's also just hanging around in there. It can cause a number of problems. So,
and it would just drain right down into the boilers?
No, in Brent's instance, he's pretty safe because there's a T there, but it'll all pool at the base of the stack if it occurs, so that's not great.
Okay, so visualization, you got that massive chimney on top there. These two boilers are sitting there throughout the year. That's a big pressure trying to push air through the boilers, up out the chimney, which just takes so the boiler's working backwards, essentially. The boiler's heating the great outdoors as opposed to heating the hospital.
That's actually great. We should just baseline on that. Every boiler out there these days runs at a slight negative. So when all these stacks and chimneys were put in place, regardless of your boiler type, they are designed to have a slight negative on the stack in the worst case scenario, typically summer, right? Because you don't have enough draft. So you never want positive pressure on that boiler unless you're running like a power burner on some of your newer condensing boilers. But even then, everything's designed for a slight negative. So if everything's designed for a slight negative and the summer is the worst case, what's the winter draft looking like on anything, right? It's significant. So keep that in mind on any of your projects.
And Paul, on that left-hand picture, that's the flue that's the stack coming off each boiler and then joining together in the rectangular one there?
Yes, that's correct.
What's that black patch on the end there?
Just an access hatch, I believe.
Okay. Does it leak?
Oh,
No, not coming down, but can air get through? Is that really well sealed so the air can't just scoot straight up the chimney through that? Okay, good stuff.
That shouldn't happen either if you have adequate combustion air in any room, which is governed by code. So unless someone starts blocking off air intakes because it's cold in the room, which happens all the time, it's very difficult to downdraft through an offline boiler. But it happens.
Right. Paul, for a moment, talk to us about, here's the economizer, and is that the draft damper above it?
Yeah, so there's an actuator right smack dab in the middle of the economizer on the photo on the left there. We found that's not even powered. And the position of the damper blade in the middle is unknown. This happens all the time. in any facility anywhere in North America.
So that
Very, very
actuator is connected to a damper which opens up when you want to bypass the economizer, so then it's not recovering heat anymore.
So if the damper's open, the flue just goes straight up the stack as normal. If it's closed, it forces the flue gas around the heat exchanger, you recover heat. When we do dew point controller, we look at the temperature above the economizer and we throttle that damper to maintain a desired outlet temperature that we believe is safe.
And the dew point says that that's trying to prevent condensation.
Correct. There's a known dew point of natural gas based on excess air. So that's a curve, and so we'll know where to set that temperature based on where our combustion's at.
And John, you've got a lot of experience with economizers, older ones. Can you give us some anecdotes there? And then again, I'll let you go back to the room and questions, comments from everybody else, because all of you've got some of these things.
So Paul's right. On those damper motors on the economizers, we had some serious problems and they weren't working. Where we thought they were open, they were positioned and closed. After doing some follow-up with our technicians, they had sourced that we had to replace it because it wasn't even moving at the time. Sometimes it would just nudge, but you would look at it straight and you'd say, oh, it's open, but it's not even close.
Was that the damper or the actuator?
The actuator.
You replaced that?
Replaced it.
Got it.
Yeah. So right now, I mean, it's been working. We keep a close eye on it, and we do have temperature readings above and below. So we keep a good track on that to make sure that those dampers are functioning. The problem I think we had a lot with that situation was we used to run on oil in the winter times. So we're on interrupted fuel. We don't do that anymore. We decided maybe 5 or 6 years ago to go off interruption. But that's where I think a lot of those problems happened because the stacks would get full of soot and we had nothing but problems.
And you found that the economizers were pretty fouled as well, right? I think you cleaned them up.
Yes, we did. We spent quite a few dollars on that at one particular time. Yeah, we had a lot of problems. That's why we had decided, is it all worth to go uninterrupted fuel?
That's actually a very interesting question. Again, the government's looking at that as the same interruptible fuel deals with that peak, right? If people won't use interruptible fuel, we need more gas pipes and things, and we don't want to be spending money on those right now. Brent, how do your operators, like what issues, what challenges did they have? And then we'll get to the draft damper because you can point out where that is. But this setup around the economizers, the draft dampers, that whole configuration, what issues did Rob have to deal with?
Yeah, in particular, I don't think that if the boiler's running efficiently based on the parameters that the operators can monitor, some of those things I think go beyond line of sight. So, and then it's an unfortunate waste of energy and resources. And I think that the more line of sight you can have from automation or from just indicators on certain components themselves, I think make everyone's life a lot easier in the plant from an operating perspective, and then obviously turn out to be a benefit from energy and energy efficiency.
Right, you're looking to get more visibility of what's happening in these into your front end of your building automation system.
Correct, yeah. Whether it's automation or, like I said, having something as an indicator for line of sight that could be added to a boiler plant checklist, just ensuring that every little component is where it needs to be based on seasonal differences, etc.
Any other questions, comments, observations from the floor? Mike with the mic. I just have to say that once in every session. It just you will tire of it. Please don't say that.
So for those boilers with the stacks, do you still need the giant stack if you retrofitted forced air fans? So therefore, you just don't need the stacks anymore, but you just have them because they're air.
I mean, someone designed the draft on that boiler plant a long time ago, and it's got as much to do with the performance of boilers as it does with the architecture in the area. So Southlake is a giant horseshoe type building, and there are some very bizarre wind patterns that can occur there. So I suspect that's why the stacks were designed the way they were when they were put in. But I know a lot of your hospitals, and some of you have retrofit into old brick radial stacks just because, it was there, it was easy to put a liner in, it provided satisfactory draft. Like that photo on the right side is the draft damper above the economizer that was installed at the time. The same thing, it's way up there, It's almost impossible to know, like there's no instrumentation on a lot of these older plants to understand what the position of that actuator is. So, you know, even if you put these measures in place, you might need the draft in the summer just to maintain on the boilers, right? Especially as you really tighten up combustion, you still need a slight negative at all times. So I don't think you can cut down stack measures. You just have to control them.
And the right side picture there, above the economizer, that's the draft damper, right? Can you give us a quick summary of what the draft damper does? How should it work and what's it doing right now as far as we know?
So as I noted, the old stacks are designed typically to induce a slight negative at all times. And that's because it's a lot cheaper to break draft than induce draft. So if you want to induce draft on a plant, you got to put an induced draft fan. You're expensive, you're running a motor, you're pulling. But if you run your stack so it's always at a slight negative, you just put a throttle on the stack to break the draft, and that's what keeps you in control. So that's basically just a damper blade in there. You can get really tight control through a multi-blade damper arrangement, but it's there just strictly to break the draft to the requirements that we want. It keeps stability across the range.
So if these aren't working properly, what happens to the efficiency of the boiler? How does that affect the boiler?
It declines because you're pulling the heat energy through the boiler at a rate that it's not supposed to be, and you just cannot absorb the heat energy. So it's just bypassing the boiler and going right up the stack. It also can cause problems. You can have nuisance trips, you can have fluttering, you can have combustion events if you're not careful. So there's a safety piece to that as well.
So going back, the work is going to be, let's get the dampers on the economizers working properly so that the flue gases are going through the economizer when we want the heat, and let's get the draft dampers working properly so we don't have too much air rising. Let's go through some more pictures and just pick up anything. This is the feed water pump on the right, right?
Yep.
And so if you want to, how are you going to shut the condensate off when the boiler is not running? How are you going to stop that condensate going through the economizer so essentially it's giving up heat rather than...
So every boiler out there, especially if you're modulating feed water, which the majority in the room are, I've been doing most of your hospitals, but you have to have continuous flow across the economizer to stop flashing, right? Because you can recover enough heat energy that if you restrict flow, it'll actually flash the steam in the economizer and it'll fail, cause problems. So every one of these economizers and feed water pumps are installed with a fixed orifice bypass. So you're always bleeding a little bit of flow back to your feed tank deaerator. So there's two purposes for those orifices. One is to protect the pump from deadheading. So if your boiler stops calling for water, that flow's got to go somewhere or you destroy the pump. So you've always got a trickle back of water on those orifices. But in addition to that, every economizer should have a bypass orifice, again, to keep them wet. In Brent's case, he's got 4 boilers, 4 economizers, and so all those economizers are always seeing feed water bleeding past them, whether they're running or not. So why send hot deaerated water through a heat exchanger in an offline boiler? So now we're taking heat energy out of the economizer if you're not putting it in, and you're losing energy. Plus, you're just diverting unnecessary flow. So we're looking to address that with an on-off valve that'll be commanded by the boiler. So you cannot run the boiler if you don't have flow in the economizer.
So there's new solenoid valves, something like that?
We're looking to encourage a more robust solution than a solenoid. They can be problematic, but yes, it'd be an on-off valve.
And will there be a variable frequency drive on the feed water pump or not?
One can look towards that. Traditionally, because of all those bypass orifices, the payback's been here nor there. But as you implement more technology, you can get feedback from the system to say, I've got so many boilers, set the pump to here. So that is something you can consider in the future. But these are the stages I think you should know.
Yeah. So, yes, Archie.
I do have a question for you, Paul.
Mike with the mic.
So the new boiler have the controls which tells you if the economizer fail. If the old boilers, how you could detect, is the smoke can tell you, the color of smoke can tell you if your boiler economizer is not working?
Well, failed or not working?
So for example, if it's not working, it's not fully functional, your economizer is not fully functional, the new boiler have the controls which tells you if it fails. But if I'm talking about the old boiler, like for example, John Place, which I visited, I know is you have an old boiler. So is there indication, any kind of a color of the smoke, anything you can tell that other than to go and troubleshoot and find it out?
No, the only way is temperature indication.
Okay, just
Because you're not influencing combustion. You're just recovering heat energy. So in fact, the hotter the stack is, it should be. You can see any. So literally, and to Brent's point, most of you are flying blind. We used to cut costs on adding, gauges and certainly technology to relay those points back to the front end a lot. Like that's only something we're doing routinely now in the last 10 years. So the only way you're going to know that is through temperature, and if it fails, you'll see steam. So you will see white. It look like smoke, but it's steam. And so if the economizer fails, it's misting into the flue gas. It's changing phase into a vapor, and you'll see it in the stack.
Yeah. When I have a mic, I also have a question, not regarding the economizer, but also about the tube failure. So the coil tube sometimes fail, and by the time you notice, it's too late. So is there any indication where you can find it out if your coil is failing and because sometimes it's too late when you open the boiler, you find, is there an indication?
Whether it's a coil tube, water tube, or fire tube, it's a heat exchanger. And so in any of those instances, there's two sides for a failure mode. There's the water side, so you need flow, and you need a clean flow path. So if you start building up scale, all your heat energy is going to the exchanger and will create a failure on any boiler type. On the flue side, if you start sooting up, so you start creating carbon on the outside of that, once again, you're insulating the tube, you're overheating it, you will fail. In the instance of a water tube, forced circulation or traditional, you can freeze them because you have high heat transfer values. So if you get that downdrafting, you can absolutely freeze and split the coils. But those are your primary failure modes. So you need to keep the water clean and the combustion clean. Otherwise, you start to dump the heat where you don't want it. And flow is critically important in any boiler, any heat exchanger for that matter. If you don't have the sufficient flow at all times, you will fail.
Is there a software sensor that gets you when you're not having to look at the options?
Yep, these boilers come standard as most with both indicators on the heat exchangers themselves as well as stack temperature. So as you see heat exchange start to decline, so you've got scale or soot, you're not taking the heat energy out of the flue and it's going up the stack. So your stack starts to elevate in temperature. So these have lockouts on temperature control, as many boilers will. But these days we've got the technology where you can track that and start to get alerts and say, like, I'm drifting 50 degrees over the last 3 weeks, something's going on. And you can get ahead of that.
Right, the panelists will be around at the break, so take the chance to further questions. I think the rest of these pictures kind of are similar. They cover some of the areas. Let me know, Paul, if you see anything which is worthy of
Should we go back to that one?
Go back to that one.
See the one on the left? You know how we knew the damper was failed? There was no lights or power on the panel at all. So how's it working if it's not powered? So that's a good indicator. That's like,
Yeah.
that was a long time ago because we didn't take that up for a long time. But like to John's point, traditional methodology with economizers, these days if you're a gas-only plant, most manufacturers will fix your economizer closed, so you're always utilizing heat. But when you had dual fuel applications and you put the boiler in oil, the damper would be fixed into that safety string and it would lock open. But if you're only doing that once a year, pumping oil, they start to bind. And that's why they're left. Because it's like, well, whatever, we're just doing it for oil anyway, it's not that important. Plus they're way up in the ceiling and you can't shut the plant down sometimes. So this is why it happens. It's no one's fault, it's just a byproduct. If we're aware, we tackle it.
I have one more question.
Yeah.
In terms of the stack, aren't those built for dispersion needs to facilitate? And so when you change the flows out of the stack, is that, making it go less? I know we do certain things for safety, it costs us energy. So is that, there's no issues as it relates to the dispersion from the stack if you start changing these things?
I mean, in theory, if you're very tight with your combustion and your draft control, then yeah, you won't have the dispersion, like you won't have the velocities coming out of the top of the stack. However, we're combusting exceptionally clean, right? So that's what we're managing at the boiler. So it's, and besides, those stacks are designed at such a height at Southlake that they're sending it over to Orangeville.
My second question, it relates to some of the technologies like adding additives to the flow, to the fluid to increase or resistance improvement. Is any of those things viable?
You mean like injecting like urea into the stack?
Well, no, in terms of the water system.
Well, I mean, water's like, funny, we used to get a lot of flack because a low volume boiler requires clean water, but if you want to do anything clean, like if you want to have clean combustion and decarbonize, you must run an exceptionally clean water
Water,
system.
okay, thanks.
Not just boiler, heat exchangers too, all of them.
Let me move this along because I'm conscious of the time. So what you're hearing here is kind of interesting technical stuff about improvements you could make: steam pressure, draft dampers, economizers, boiler sequencing. All of those things materially improve. So the first step of 6 generated a 4% gas reduction. We're predicting, and we'll see how it all turns out, and what Julian's maths tells us, that we'll double those. So we're expecting to see that plant get maybe 8-10% improvement, and through the summer even more than through the winter time. So technically, everybody, and you can check off on the checklist those things. What we think is more important here is this dynamic here. We've got Enbridge, we've got the hospital, we've got peer support, people that have done this before that you can talk to, and we've got the service contractor working together on comprehensive solutions. We can't get to where we need to go doing one project now, and then 3 years from now we'll find another one. What does that package look like? So that's the model I'd like you to take away. We sent a final notice out on this session, say bring your boiler service contractor with you, because we'd love to have those sessions where we all talk together about what's possible. The checklist covers most of the things we can think of between us that you could do. Take a moment to fill that in, but there's a challenge left for these guys before we let them back to the seat. So combustion test reporting matters. So on the left-hand side there is one of half a dozen charts that come, your excess air. So there's a whole bunch of potential charts that come out of your test reports. Without being pejorative, the majority of hospitals never even look at those reports. You say, are we okay? Yeah, we're okay. Check it off, put it in the file. They're trying to tell you something. Every one of these test reports has a story to tell. You can see as firing rate goes up, efficiency goes down. You're trying to get more heat out of the gases and the stained gas temperature. That curious looking chart at the bottom there is one of the comparisons we do. That's a whole bunch of different hospitals. So as you're doing this testing, and again, Thermogenics and Southlake are going to be doing the testing once they have enough load on the boilers. Please don't test them under light loads because you just can't get reliable information. We can compare hospitals with each other. We can tell your individual boilers how they relate to each other, and we can tell you how your hospital compares to other hospitals. Combustion test reporting, raise it to another level. It's not just a check the box, we did it. It's a diagnostic tool that you can use to identify opportunities. Anybody seen anything like this before? Boiler operating logs, it's the same thing. Your operators, day after day, take the time to write these numbers down. They do it religiously, they're required to do it. Information, data matter. There's gold within here trying to tell you a story about where the improvements can be made. So, how many of you do have electronic versions of this in play right now? I'm interested to know, as opposed to doing this, because the majority of hospitals do exactly this. So
We don't have one, but we are looking into this to be
okay.
like it.
So as a minimum, I believe the contractors, and there's a number here today, can tell you what products they have, proprietary or otherwise. We just translated those charts from Southlake into Excel, and we'll send this to you and to Rob. So here's all the information that's there. Now you can trend it. Now you can look at the anomalies. Over on the right-hand side, because Julian was good enough to dig up the interval gas data, we added to that log how much gas we use every day. Now we got something powerful. We know how much steam we produce. We know how much gas we use. We know on the right side there how much makeup water we used in 24 hours. Now you're turning this into a diagnostic analytical tool that you can use to maximize the efficiency of your plant. And we're saying this is one of the measures on there. Please kind of check that off. This is just us playing with numbers, but we'll be spending a lot of time with Paul and other contractors. Let's get the meaning out of this. So the orange one is gas use. How many cubic meters of gas per 1,000 pounds of heat? And look at the scatter. So that's essentially the efficiency of the boiler, but you can see the scatter moving around all over there. There's some outlier points. On the left-hand side, the blue ones make up water in liters per 1,000 pounds. Kind of how interesting is that? What do the high points mean? What do the low points mean? And somewhere in this 12-month period that's tracked here, those linkageless controls got installed. So we haven't, again, this has just run the last few days to show all of us what's possible. But somewhere in there, there's a story coming up. So you can see it's fairly tight. The blue points on the left-hand side. It gets much more scattered in the middle. Somewhere in there, the linkageless controls went in. So we'll be working with Southlake and with thermogenics on what does this mean, and does it give us further clues on how we can further improve the plant. But the idea of updating your boiler testing process and getting the data, getting the knowledge out of it, and your boiler operating logs was the other key message we wanted to leave there. Again, thank you, panel.